Objective-C was found by Brad Cox and Tom Love in the early 1980s. It was based on the famous C language. Even though C was a very efficient language, there were some features missing in it. It was not capable of object-oriented features. But the language, Smalltalk, had object-oriented features. In 1980s, C language was extended to support the object-oriented features of Smalltalk. That was the creation of Objective-C.
History of Java.
Java was the first operating system and microprocessor-independent language. Up to this day, Java has changed a lot. New classes and packages were added, improving the language.
Who uses these platforms?
Platform developers, mobile application developers, mobile users.
Android and iOS developers use these languages. They use different IDEs and emulators. Things like cross-platform deployment, installer options and development cost are also different. Comparison of the two platforms can be seen in this table.
Mobile application developers.
Mobile applications for the above-mentioned platforms are developed using Java and Objective-C. Different development tools used by developers are listed here.
Mobile users.
Sometimes, mobile users get different features due to the differences in the platforms and the languages used. Some of these are advantages and some are not. For an example, Android platform has features like true multitasking, flash support, near-field communication, Wi-Fi hotspot and USB on the go. iOS users get better battery life, smoother scrolling, and ad-free content.
System architecture.
Architecture of the Android platform can be seen in this diagram. iOS architecture will be explained here.
Objective-C versus Java.
The way how variables are defined in Objective-C is very different to Java. Since Objective-C is dealing with pointers, developers have to be aware of memory management. The definition of variables is much more complicated and powerful than in Java. Attributes. As you can see, Java and Objective-C have the same attributes.
Java interface.
Interfaces are used very heavily inside of Java applications. They allow the programmer to decouple different parts of the code and to make them independent. Additionally, they're used to define a contract which specifies methods which have to be implemented by subclasses. It is very comfortable to code against interfaces rather than implementations.
Instance variables.
Java An instance variable is an attribute from a class's instance and exists for each instance. It will be initialized during the creation of the class instance. Instance variables can only be accessed by class instances and not by classes. Objective-C. Variables are defined in the .h interface file. If you do not define something special, the attribute is visibility protected. You can use it in the .m implementation file and deal with it. Also, subclasses of class can access the attribute.
Class variables.
Java. A class variable is an attribute of a class and exists exactly once by class and class loader. It will be initialized at class loading time and can be accessed by classes and class instances. All instances of a class will share this unique state of the variable. If you change the variable, it becomes changed for all instances of this class. Objective-C. This variable can only be used inside of the class which defines this variable. Another very confusing behavior of static attributes is the fact that they can be defined inside a method and will retain their value during subsequent calls. For instance, the singleton pattern uses this very heavily.
Visibility modifier.
Java. Java decides 4 different visibilities: public, visible for all objects; protected, visible for all subclasses and classes in the same package; private, only visible inside the class; default, only visible for classes in the same package. Objective-C. If the attribute should be accessible from other classes, you have to use visibility modifiers. Please note that static attributes are always private.
Final modifier.
These examples will show how Java and Objective-C use final modifiers.
Objective-C protocols.
Objective-C provides a similar approach called protocols. Protocols have a very close semantic as interfaces, but allow you to mark methods as optional. Optional methods can be implemented by subclasses, but it is not required. Protocols are defined by the @protocol directive. It really looks very close to the Java declaration. Also, the implementation class of this interface is very similar to Java.
Conforms to protocol and instance of.
If you would like to test whether a class implements a protocol, you can use the conforms to protocol message. It is similar to the instance of check from Java.
How to call a method.
The way how methods are called in Objective-C is different to Java. If you are doing your first steps with Objective-C, it seems that sending messages to an object in Objective-C is exactly the same as calling methods in Java. A different syntactic way. But sending messages and calling methods are two completely different things in Objective-C. A sent message will be converted into a method called by the message retrieving object. In Java you just call the method. In Objective-C you do not directly call methods for normal. Instead you are sending messages to an object and let the message receiving object converts the message to a method call.
Java class.
The following image shows a very common Java class implementation. A Java class consists of 4 different parts: a package name, the class definition, definition of instance variables, definition of an instance method.
Objective-C class.
To define exactly the same class using Objective-C, we have to create 2 different files: a header file and an implementation file. The header file specifies the public interface of the class. The implementation file contains the class's implementation. If methods or variables should be accessible by other classes, you have to define them in the header file. Otherwise the compiler would send a warning.
And first you need to create a new Android project, and for that go to File, New and Android Project, and create 2 new Android project. You must give a project name. I'll give Hello World. And go to next, and you must select a SDK, and I'm using Android 2.2 Pro, and API level is 8. And next, and application name is Hello World, and you must give a package name. I give first my name, and click, and this is the Android activity, Hello World activity, and minimum SDK is API level 8 and click finish. And this is the project. It includes src gen SB array. In this rest folder, all XML and the graphical files included in here, and in src file contain our created package, and inside of that has our activity file, hello world activity dot java, and go to main.xml. First, to develop hello world, first we need to create user interface. To create user interface, we must go to the main.xml file, and the main.xml file is contain the user interface, and you can see this is the graphical layout of our application, and this is the coding of that. And if we want to add another hello world, I simply copy this, and this contain a string in our values folder. It contains strings.xml. This is the string.xml file. We can add strings. I add a new string, add string. Okay, I give first name. I give hello world, and value. Uh, the value is the only to preview. The name in previewing only coding, and I give value welcome to the Android world, and okay, I go to again main.xml file, and I delete this hello, and I give the name. I give it to it hello world slash